A very warm welcome to everyone who's joined today's webcast, 5 Ways Bias in Machine Learning Could Be Affecting Your Organisation. I very much hope you enjoy the webcast or the conference, and if you do have any questions throughout the session, please do post them in the chat pane. We will be sure to get back to you with answers to those as soon as we can. So go ahead with any questions. Let's just dive into the agenda first. So we'll be beginning with sort of setting the scene period, where we'll just be discussing sort of the background to machine learning, the business uses, and why it's so important to adopt in today's world. And then we'll be doing a deeper dive into machine learning and also the bias, how bias can arise, and then going on to how we can actually reduce that bias and some techniques to do that. We'll then be diving into a demonstration by my colleague, Harpreet, who will be explaining a very interesting and exciting way to reduce bias in machine learning. So we'll get some hands-on, well, not hands-on, he'll be getting hands-on and we'll be observing that. And next steps will be the final section of the webcast, where we'll look at how we can actually leverage this technology in a safe way that doesn't cause bias, and looking at a few more examples. So that's our agenda for today. I did mention my colleague, but just a quick introduction before we get started. My name is Natalie and I'm a data and analytics consultant here at Thorogood. I'm very excited to be presenting this webcast to you today. And I'm joined by my colleague Harpreet, who is also a data and analytics consultant, and he will be, as I said, taking you through the deeper dives and also the demonstration, so you can look forward to that. Before we start, a little bit about Thorogood for those of you who aren't familiar with us. We're a specialist data engineering, data science and data visualization consultancy with over 30 years of experience delivering solutions to leading enterprise organizations. And those solutions are always going to be based on our founding principle, which is always by looking to lock onto business goals. And we then unleash the technical and analytical capabilities that we have to maximize the opportunities from business objectives. And we maintain this business focus across a range of delivery areas, right through from initial strategies and roadmaps, proof of concept and pilot delivery to the full solution implementation and a wider rollout of that solution. We are a specialist independent consultancy which operates globally, but I will go into a bit more detail about what we mean by independent later. So that's a short introduction to Thorogood for those of you who aren't familiar. And you can see we've just got some of our current and previous clients down at the bottom here. So just a little idea of who we've worked with in the past. So the first thing to note about machine learning is that it's everywhere and its presence is only decreasing. Some examples that you might already be familiar with are noted on the screen. So your email spam filter, your credit card's fraud detection service may use classification algorithms to detect where an email or a transaction is likely to be unwanted or fraudulent, and they'll base that on relevant attributes. Netflix or e-commerce websites might use a cosine similarity algorithm, bit of a mouthful, but there you go, to recommend films or products that they might think are more likely to suit your tastes based on the preferences of others with similar histories and tastes as you. And then we've got this sort of credit report. Obviously, lots of companies use things like this to predict your eligibility for things like loans. So machine learning, to conclude, is absolutely everywhere. But why should your organization adopt it? Well, I know we're virtual, but you know, if we're all in a room together and I ask you all to put your hand up, if you felt the pressure to progress along the analytics maturity curve, I'm sure lots of people would be raising their hands. Progressing along this kind of journey of maturing your analytics is something that's really becoming quite crucial to maintaining that sort of market edge, that advantage. It's not really enough to be able to say what happened yesterday. That's in this kind of reporting section here in the grey. What's more important now is to actually be able to predict what's going to happen in the future. And that's for a variety of reasons. But lots of companies are doing this. So to maintain that market advantage, it's becoming quite a crucial attribute of your analytics capabilities. And it's not just market edge anymore. We are facing a period of likely instability economically. And we've got a quote here along the bottom from Jamie Dimon. I said there's storm clouds, but I'm going to change it. It's a hurricane. And he did go on to say he doesn't know how big the hurricane is going to be. It could be a small hurricane, it could be a large hurricane. But either way, he is predicting a hurricane, an economic hurricane. So businesses are going to need to weather such a hurricane. And I think, again, something we can all relate to is the need to kind of start looking at your costs a lot more, scrutinize your costs a lot more. Everyone's going to be wanting to preserve profit margins. They're going to want to reduce costs wherever they can. They're going to want to shorten timelines, which obviously reduces costs as a downstream effect. And they're also going to want to find new areas of revenue. All of these things are going to come together to preserve profit margins. Now, this is a whole new pressure on the general pressure to advance along this analytics maturity journey. If you can bring machine learning into your organization, you are going to be able to execute in all of these areas much more efficiently and much more sort of potently than organizations who aren't able to adopt machine learning. Let's consider a few examples. So automation is an obvious area of cost reduction. Avoiding costs, reducing the human involvement in those easily automated, tedious workflow tasks. Things like hiring, you can again reduce human involvement, sort of save on employment costs by having ML do some of that initial sifting through CVs. And then if we think about shortened timelines, again, that's an obvious area that automation is going to be a huge player in that game. And we can also think of things like predictive analytics in reducing your need to do trial and error or try a few different proof of concepts to see what works. You can actually use some quite reliable models to predict what is going to work and what's not going to work, and then go ahead with that solution all guns blazing without wasting time on kind of dipping your toe in the water and having a go. New areas of revenue. I think a great example here is things like rewards at, let's say for Starbucks, if you're getting an iced coffee in 35-degree heat over and over again, it's going to start to learn that people want an iced coffee in 35-degree heat. Now, to be fair, you might think this is something they kind of already know and something that should be quite obvious to any human being, but you can see how this would help them to link certain external data with what their customers are doing. And with this new information, they can then start to sort of push offers to you that are going to drive you to get that iced coffee when it's 35 degrees. So maybe you weren't planning on getting a coffee at all that day. Since you've been given this offer, you'd think, actually, that does sound quite nice. So here we're finding new areas of revenue, and that's another way that machine learning and its adoption is going to help you to preserve profit margins. So I think the conclusion is that the pressure's on to adopt machine learning, not just from a market advantage point of view, but also when we're thinking about the CFO side of things, looking at the finance and keeping those costs down, it's another huge factor in that. So let's think about how we can adopt machine learning once we've decided that that's what we want to do. You can adopt machine learning using a variety of different tools. Each of the cloud providers tends to have their own sort of machine learning based offering. And these are a few examples of those technologies that are offered, and actually technologies that we use at Thorogood quite a lot of the time. So as we can see, we've got GCP's dedicated tool of the Vertex AI. We've got Amazon SageMaker, Azure Machine Learning, not so creatively named, and then Databricks MLflow. And it's important to note that Databricks does have a few other sort of dedicated machine learning tools like AutoML, but for now we've just got MLflow up on that slide. I did say that we're an independent consulting firm earlier, and just to clarify, this is a great example of how we are independent. We aren't just focused on one technology or one cloud provider. We actually do work with all of these providers and their dedicated offerings. That gives a little bit of credibility to what we're going to be speaking about today. Another way that we build on that credibility with these technologies is that we are actually partnered with a lot of these providers. As you can see, we're AWS, part of their consulting partner network. Also a gold partner with Microsoft. They're a very key and important partner for us. We've actually been a gold partner for about 15 years or over 15 years, and we've held seats on their Global Business Intelligence and Advanced Analytics Partner Advisory Council for about the same amount of time. That's also quite a mouthful, so apologies there. But we find that pretty useful for providing feedback from our customers and things like that. We're also partnered with Databricks, another very key and close partner. We've spoken at their AI summits and things like that. So yeah, as you can see, we definitely are not tied down to any one particular technology. So as much as there's lots of pressure to adopt machine learning, and this pressure is getting more potent and kind of accelerating at the moment, especially, there are a lot of dangers in adopting this technology too hastily. This is not something that can be rushed. You can see there's a lot of different technologies in my previous slide that help you to adopt ML, but none of them are simple. They can be user-friendly and intuitive, but machine learning at its core is a very complicated science, as you'll learn later on, and it can't be rushed. So there's a lot of dangers to kind of going with the flow and following the trend and just churning out machine learning as quickly as you can without thinking too much and planning for it. And I think we're seeing the consequences of that quite a lot in the real world. So on the screen, my apologies, it is slightly blurry, but hopefully you can make out the text. This is a screenshot from the Google Translate, and it was actually taken from a tweet from someone complaining to Google. And just to be clear, they have rectified this, and Google actually has their own offering for reducing bias in machine learning now. But this was a couple of years ago now, and essentially a lady has attempted to translate gender neutral language of Hungarian into English. And what you can see is that Google Translate has actually assumed the gender of the subject in these sentences from the adjective that they're using. So we can see she is beautiful, he is clever, he reads, she washes the dishes, he builds, she sews, etc. So we can see there's sort of unconscious bias, or we hope it's unconscious, in the way that the machine learning model is translating this text. And it's basically learnt to link these actions or these adjectives with a particular gender, thus stereotyping, obviously, these actions to be linked with that particular gender and causing a great deal of harm and damage to the modern world that we live in now. So you can see this obviously did not do great things for Google's reputation, and also made a lot of people quite rightly very angry, including myself. So this is a very key example of how this bias in machine learning can really have some pretty dire consequences if you're not careful. We've got another example here, this technology called Compass, which was basically a prediction algorithm developed by Equivant, and it was meant to be able to predict the likelihood of a prisoner reoffending in the future, thus kind of theoretically freeing up prison space for those who weren't likely, not for those who were, for other prisoners, while those who were deemed less likely to reoffend basically may get an early release. But the algorithm was found to be racially biased in that it kind of disproportionately predicted that Black people would have a higher risk of reoffending than white people, which is obviously a huge area of bias in this model and extremely damaging and extremely very offensive because of the obvious racial bias. So again, you can see there's huge danger in bias in machine learning, and it's not just about having a bias which results in a cost implication, and it's not just about reputation, it's also about having real world consequences and causing a lot of damage. So here we have a sort of storyboard of how this kind of damage can really manifest itself and spread between several different business functions. We talked about the real world harm here on the left from discrimination, essentially, in bias models. And this obviously has huge ethical implications and also reputational implications. So if you are going to make the internet and the world very angry with a very biased model, then you're probably going to lose quite a lot of customers, and you're going to affect your reputation in quite a damaging way. You also risk being non-compliant to a lot of standards which basically exist to try and prevent this kind of thing. And non-compliance can also be incredibly costly and cause a lot of problems internally. So you've got these two kind of arrows coming from Well, there's two key directions from these ethical issues. One of them is the very real world harm, probably the most important thing, obviously. And then the other thing is that we're coming into cost, which is a much more sort of materially significant implication for businesses. We've also got, if you have this machine learning bias, slightly less glamorous, well, not glamorous, but slightly less potent, but still very significant side effect, which is that you're going to have a reduced efficacy in your machine learning model and then a reduced efficiency, which is going to lengthen timelines, maybe cause you to have to go and look for that bias, correct it, maybe build it all again if it's not viable, or it's going to slow down the process that it's meant to speed up. All of these things could be very costly indeed. So you can see there's a lot of different ways that your business can suffer from bias in machine learning. Definitely not 5, definitely more than 5. That would sort of conclude what I wanted to speak to you about today. And with that, I will hand over to my colleague Harpreet, who's going to speak to you about sort of a deeper dive into machine learning and bias.
Now we'll get into just talking a little bit about machine learning and just diving deeper into like where bias might arise within the machine learning cycle. So how does machine learning actually work, and what are the key steps in a machine learning initiative? Well, we'll start with some data, and as I walk through this example, we'll have data on people that may or may not be professional athletes, just to give an example. So we'll have a data set that contains information on a group of individuals, such as their weight, height, their 100-meter sprint speed, their credit score, their eye color, their month, their birth month, and of course some other features. Ultimately, the target would be whether or not they are a professional athlete or not. So like the attributes such as their height, weight, and credit score are features, and the label is whether or not the person is a athlete. And when an output or label is numeric, like salary, this is a quantity, and we may want to look to use a regression model to predict a quantity. But in this case, we have a label that is discrete, so it'll be more of like a classification task, more so a binary classification task. So after cleansing the data for use, we split it randomly into a training data set and a test data set, and now we can select which features we want to use and how. So in this example, like if we were trying to predict whether or not someone's a professional athlete, something like their birth month or their eye color might not hold as much relevance as per se like things like their height or their 100-meter speed, which might have a better correlation with whether or not they're professional athletes. So within this step, within the feature engineering step, we can go ahead and select those features that we think are more relevant into getting us our target label, and we can drop the other features so that the algorithm isn't really generalizing on those observations. And so when we select an algorithm for a model, we'll explore how we decide on an appropriate algorithm to use. So in this instance, we'll just use like a basic clustering algorithm that groups people based roughly on their height and 100-meter speed into athlete or non-athlete clusters. And we feed our model training data so it can create these cluster groupings and establish the clusters of values that lean towards athlete or not. So here we're feeding our training data into our model. And then we can run our test data through this trained model to understand how accurate the model is. And we can see the result of the evaluation from our model alongside the actual value. In this evaluation, we can look at how many athletes we correctly identified, how many non-athletes we incorrectly classified as athletes, and etc. Since this would be a binary classification task, we can look at that matrix, just looking at like our true positives, false negatives, true negatives, just to get a sense of how our model is performing. And then we are also able to iterate over time to refine our model by using different features or different algorithms as we deem appropriate. And ultimately, we can look to industrialize our model through the process of MLOps, where we automate the feeding of data into the model and the execution of the model. So here we can see that after we have our model, we can just keep iterating it, feeding it new data, making sure that it's up to date and it's picking up on the most recent data and generalizing with what the real world data actually is. So this was just a basic example of a basic machine learning task where we get data, we split our data, we do some feature engineering, feature selection, we choose a model, we train our model, we look at how our model performs by using their different evaluation metrics, and then from there, either we choose to redo everything using a different model if our evaluation metrics aren't meeting a need that we have, or we can just go ahead and use this model and then just iterate over it, just making it better and better. So now that we've seen how this works, now let's take a look at how bias can occur at multiple points within this life cycle. So the first place where bias may occur is the initial data can have bias that may stem from the labeling process of the labels. So data can be labeled by humans. Data can be labeled by humans that may be biased, which can then mislead the ML algorithm into learning these biases. So sometimes data is labeled by humans, and if for any reason there is any bias during the labeling process, that bias will inherently be also recognized or generalized by the algorithm. And another way initial data can be biased if it is comprised of limited records or features that are not well represented. So for example, for a feature X, there may be only two values, A or B. Now, if there are a lot more records for the value A and very little for value B, the algorithm would generalize pretty well for A, but not for B, which would lead to a bias stemming from underrepresentation. We can also introduce bias in our next step within the ML lifecycle as well, where we split our data into training and test sets after applying transformations. Here, bias can come if our training data set isn't fairly distributed across all of the classes of our data. So the ML algorithm will actually then be trained on the data set favoring a class and will perform poorly on the test data due to it containing the observations of the other class. So if we take our example, we were talking about athletes, and so if we split our data up into training and test, and for some reason all of our actual observations that were athletes were in the training data, and we had very little non-athletes in the training data, and our test data was mostly made up of non-athletes, then the model will generalize well over athletes and wouldn't really understand how to generalize over the non-athletes. So that would inherently cause it to have a bias towards athletes, and it would be able to pick out those better than the non-athletes. So that would be another way of bias if we're not randomly sampling the data when we're splitting it up into training and test, and making sure that all of our target variables are well represented. And as a waterfall effect, if there is any bias in the previous steps, this can lead to the actual algorithms becoming biased. And in turn, if the model is retrained on predictions, then the cycle of bias just keeps happening. So if there is a bias that the ML algorithm generalizes on or picks up on, and then we're using the same prediction values to feed that same data back in to retrain the model, then the cycle of bias just keeps occurring. So now we'll talk about reducing bias, and so we'll talk about some common instances of bias and ways to reduce it. So just a little deeper dive into the common areas. So now that we've talked about where bias can occur, let's just take a look at some of the common instances of bias in machine learning. So the first is reporting bias. So this occurs when the frequency of events, properties, or outcomes in a dataset does not accurately reflect the real-world frequency. So if the data set that we have does not actually match the real world data in terms of the observations that we have or the frequency of events, we'll call that reporting bias. There can be selection bias. So this occurs when a data set's observations are chosen in a way that's not reflective of the real world distribution. So selection bias can also have different forms within it. The first is coverage bias. So this is when a data set population does not match population that the ML model will be predicting about. There's non-response bias. So this is when participation gaps during data collection make the data unrepresentative. So this is kind of, to give an example, would be if we were doing a survey on people enjoying, if we were taking data of people that were using a new product, and we were taking a survey of them, of those that enjoyed and didn't enjoy the product. And if we only got the response back from those that enjoyed it, and we didn't get the response back from those that didn't like that product, then we will call that a non-response bias, because we'd only be training the model on those that actually had a positive emotion or a positive reaction to the product, and we wouldn't have the data for those that had a negative reaction. And then the last one is sampling bias, and this is when proper randomization is not used during data collection. Group attrition bias. So this is when a generalization of some individuals is applied to an entire group. So this is if we generalize an entire group of by just a few observations. We see something happening in a few observations, and we then apply that to an entire group. We'll call that group attrition bias because we're just using some observations that we've seen and we're generalizing it over a lot more. And then the last is implicit bias, and this occurs when assumptions are made based on one's personal experiences that do not apply more generally. So this is if there's any personal experiences or things that you've seen and you're applying those to the data, that can be implicit bias. So it's bringing your own personal bias into the data. So now let's take a look at some of the common solutions in terms of reducing bias. So the first is identifying accurate data. So it always starts from the data that you will be using to train the model. And as good as the data is how good the model will be. So the data used for the machine learning model should be representative of the real world frequency. Data science team should understand what the set looks like for the business use case and then gather that data. So the data science team should have an understanding of what the business use case is and what the data should look like and what that data is, and make sure that the data that is being collected or the data that they'll use eventually to train the model is matching that data. Also, transparency on data selection and transformation. So this allows teams using the data to understand how it's collected and transformed. That way, if there's any bias that occurs during this process, it can be flagged and reduced. So having transparency on your data selection and transformation, it allows different teams or even different individuals to take a look at which data was selected, what was the criteria, and in terms of how it was transformed. And it was just another set of eyes, and another team can take a look at that data and see if they see any biases, if maybe they have a better understanding of the data, or for their different use case, they might be able to identify some sort of bias that might affect their use case of using that data, which might not be found by a different team. Once a model has been trained, so assessing bias on trained models. So once a model has been trained, it needs to be assessed for bias along with the other evaluation metrics. There may be bias that the ML algorithm may pick up on, and it may not look so apparent when we're looking at the training data. So the training data might look like there's no bias or it seems to be good and everything has been verified, but we still need to verify the model. So verifying the model is accurate and does not contain much bias is important before operationalizing it. Next is monitoring models deployed in production. So when models are deployed to production, they should be monitored to see how they perform on real world data. So sometimes, even though the training data is modeled off of real world data, there can be data drift, which can lead to poor performance, since now real world data is not representative of the training data and that the model was trained on. So in these cases, monitoring can help catch these issues early so that they can be solved quickly, and we can retrain the model on the new sample of real world data and update the deployed model. A good example of this could be when COVID happened. So if there was a model that was trained on just data before COVID and it was making predictions as such, and then when COVID happened, definitely there was different spikes within data, and definitely the data was not representative of the real world data that it was transformed on or trained on. And in that case, it would have been good if someone detected data drift, then they can quickly get that data and start to train a new model and try to update that model to account for the real world changes that were happening. And the last way is another solution is tools and libraries. So besides these solutions, there are also tools and open source libraries that also help reduce bias in ML. So some of these include the Watson OpenSkill. So this tracks and measures outcomes from AI. There's Google's What If tool, which allows performance testing in hypothetical situations. It can visualize model behavior and also show different ML fairness metrics. There's the AI Fairness 360 library, which is an open source library that can help test models and datasets for bias. And then there's FairLearn, which is an open source Python library for fairness assessment and improvement. So now we'll go into the actual demo of just showing the assessment and mitigation of bias in an ML model. So just to introduce the demo, these were some of the common solutions to reduce ML bias, and now we'll show the demo showing the assessment and mitigation of bias. So this demo will be using the Python library called FairLearn to assess whether the trained model has any bias and then reduce it if found. The dataset being used for the demo is a bank loan dataset where the target variable is the approval of the loan. Within the dataset, there are many features like gender, age, debt, marital status, ethnicity, and many more. A classification model will then be trained on this data and then evaluated for bias. So for the bias evaluation, as mentioned, previously, the capabilities of the FairLearn library will be used. We will look at the metrics for the model predictions of sensitive features. So, for example, for a sensitive feature, we have a vector G for the different groups within the feature. So, for example, if the feature was gender, then the vector would be male, female, and other. And then basically, we would look at the evaluation metrics of the predicted values and the true values for each of these groups to see if the model is favoring a particular group. So now I'll go into the demo. So here we have my Databricks notebook, which I use to create the demo on. So here first I'm just reading in the data. So I'm just reading in my data and you can see what my data looks like. So here we have the different features like gender, age, debt, married, bank, customer, ethnicity, employed, credit score, and then finally we have our target label approved, which is a 1 or a 0, letting us know if the loan was approved or not. Here I'm just getting some general statistics of my data. I'm just looking at the count, seeing if I'm missing anything, getting the mean, standard deviation, the min max of the different columns. So here I'm actually starting to do some feature engineering on my data, just converting some of the binary columns to zeros and ones. I'm taking the numerical columns and I'm scaling them. And then I'm taking the categorical columns and I'm one-hot encoding them in order to take care of the categorical variables. And then finally, here is when I'm actually assessing the model for bias. So first, what I'm doing is I'm just splitting my data into train and test, and also my Y to train test, and then I'm creating a random forest classifier on the data, and then I'm fitting it, and then I'm predicting it, getting the predictions for the model. And then here I'm using metric frame from the FairLearn library. And here what I'm doing is my metric is my accuracy score. So I want to see how my true Y labels are doing against my predicted. And then my sensitive feature that I have chosen is citizen. So the sensitive feature here represents a feature if I want to see if there's any bias occurring for this feature. So this feature citizen within the data set, basically if you're a citizen or not. So that's what this feature represents. So I want to see if there's any bias occurring, whether or not if someone is a citizen or not in terms of the bank loan approval. So when I take this feature, it only has two values, so either yes or no. So I've converted that to a 0 and 1. We can see that the accuracy score for the citizen feature is if you're not, it's 0.75, but if it's a 1, it's 0.88. So here it's kind of showing that if you were not, your accuracy score, it's only accurately predicting it, like the accuracy is 75%, so it's 75% accurately predicted whether they'll get it or not. And if you are, then you have a higher chance of basically getting your loan approved. And then we'll take a look at the accuracy score in general. So for overall, our model has an accuracy score of 87%. So then we'll go in and we'll use something called a correlation remover to kind of mitigate the bias. So the correlation remover is a mitigation technique that applies a linear transformation to the non-sensitive feature columns to remove its correlation with the sensitive features while keeping as much information as possible. So we'll apply that to the citizen column and then we'll retrain the model. And then when we take a look at the accuracy score, we can see that now that our accuracy score for a non-citizen has gone up. So we've kind of reduced that bias, as before it was 0.75 and now it's 0.83. So now it's kind of gone up. So now it's generalizing and understanding that there is no correlation between not being a citizen and getting a loan approved. So we're kind of removed that correlation between that, and we can see that our accuracy for our model has not reduced. So even though that we've reduced the bias, our performance has not changed. So our model is still just as performant while still reducing the bias. I'll hand it back over to, and she'll just take you through the end of the presentation.
That was very interesting indeed. So now we're going to look at some next steps. First, I'd like to kind of highlight a few further examples of actually applying this to a real life business situation. We have a few of these sort of case studies available on our website, which are really interesting for learning about how we've actually applied these principles that we've talked about today to business problems and kind of kept honest with these goals to integrate machine learning into an analytics journey in the best way possible that reduces bias. So we have this kind of small scale project here of improve the hiring process through machine learning. You can just imagine how easily bias can creep into these algorithms when looking at CVs. Obviously a huge area of training a machine learning model would be using historical data. So if you bring in historical data that was present during any bias that might have existed in the person making the decisions, then you're going to find yourself in some big trouble in terms of who you might be wrongly discriminating against or positively discriminating for example. So little things like names, places that people went to university that university might have changed over the last 10 years, that kind of thing. You can really see how it could creep in and be quite damaging. So that's a really interesting case study to read if you want to learn about how machine learning can affect that. And that's within a finance and insurance company. So if you're interested in the finance industry, that's another reason to look at that. And then we have this other little look at a machine learning example, which is actually in the pharmaceutical industry, basically more focused on predictive analytics in general, but it's really interesting to have a look at the holistic ways that that's being used to grow sales in this example. Again, a huge focus on making sure that that sort of adoption of predictive analytics and machine learning was fair and sort of reliable. So that's an interesting one. It also touches on supply chain and consumer packaged goods. So again, interesting industry to look at. Feel free to scan any of these QR codes if you're interested in reading more. Pretty cool stuff. We've also just got a little example here of our Azure ML in Thorogood's hackathon. So that was when, we all took part in a hackathon program. And that's, again, CPG industry. So if you're interested in reading more, feel free to scan these barcodes. Super interesting stuff, usually pretty short read, and just a good way to try and link up what we've learned today with actually how we do go forth and integrate that machine learning in our projects. So that's all on the website if you didn't manage to get the QR codes to work under our perspective section. Now, just a little look into what exactly we can do. I know I touched on it briefly, but from an ML perspective, what is it we can actually do? So we can do exploratory machine learning. So basically business value driven exploration. We can use machine learning, AI, and other advanced analytics approaches. We've also got MLOps and DevOps. I think Harpreet touched on MLOps earlier. We do tend to kind of integrate that into projects where we've already put in place other analytic solutions. We have that capability to then go on to help with that continuous integration and deployment of machine learning solutions, which is really, really valuable and really popular at the moment. We've also got industrialization. You can imagine, again, another key place where you could start to see bias really affect you is when you're scaling it up. If you do have a bias that you might not be aware of, it is obviously kind of often quite a black box scenario, then scaling it up and productionizing it is only going to make that worse, and you can end up doing quite a lot of damage pretty quickly and on a huge scale. So having that done in a reliable way is obviously really important. General architecture design that kind of enables these, kind of more of an enabler of these previous points, is also something that we can help with, just looking at how to actually apply that exploratory and productionized analytics, obviously in this case in the context of machine learning. We also have machine learning accelerator templates, which are really cool, pretty exciting. As I mentioned before, we do have this huge pressure to, adopt machine learning as quickly as possible and as reliably as possible. So our kind of code templates, our code accelerator templates are a really good way to get started quickly and also reliably and start bringing in some data science and sort of maybe trying out within your organization and seeing how it goes. That's a really good option if you, again, want to keep costs down and shorten your timelines. Machine learning empowerment, another huge area of mistakes generally in data science and machine learning is if we don't know how to use it properly, or we don't know how to kind of adopt it or integrate it into what we're already doing properly. So our programs to empower users are really popular, and just making sure that the adoption of the machine learning models that you are using and the tools that you're using to do that are skillfully and responsibly adopted. So that's obviously a really important part of maintaining that reliability and knowing that that model is going to be used responsibly. So I did mentioned earlier that a lot of these technologies, a lot of different machine learning technologies are available, and they're from a few different cloud providers. And they are obviously, they have their strengths, they have their weaknesses. There's no best or recommended technology for machine learning. So I think having a multi-cloud, having the flexibility to have a multi-cloud solution is a really interesting option, and obviously keeps a little bit of healthy competition within your suppliers if you're bringing in different providers. So that can, again, drive some costs down. You don't want to be too reliant on any one technology. So it has the kind of the benefit of enjoying the different capabilities of different technologies. And also you have the option to drive some costs down with that healthy competition. Finally, analytic strategies. So how are you going to actually put together a machine learning kind of adoption strategy? Where is it going to be most valuable? Who's going to be using it? Who wants to use it? Who's going to be using the kind of outcome? All of that kind of stuff is something that we can help with, just advising on that, and just, you know, hearing from people who've actually deployed this kind of thing multiple times in multiple different industries is obviously a really useful way to make sure that you avoid making the same mistakes that others might have made in the past. So yeah, getting some advice from the pros can be a very useful route to that. Sadly, that brings us to the end of the webcast, but thank you very much to everyone who joined. I hope you found this a valuable investment of your time, and I certainly hope you have a wonderful rest of your day. Again, we've got our contact details up here, myself and Harpreet. Oh, it actually says Natalie Shepherd twice. Apologies for that. I can confirm that Harpreet is not called Natalie Shepherd. But you will find us on LinkedIn, and you can also get in touch by emailing us if that's easier. So thank you again, and hopefully see you at that next webinar.